For this lesson, 6.2, we are going to learn how to use graphing technology to make scatter plots and to find information about those scatter plots. So you will need preferably a TI-83 or 84 graphing calculator. However, if you do not have access to one of those, you can go to desmos.com, and I'll show you that website in just a second, and that's a good second alternative. I prefer the calculator, but there are directions in the appendix that tells you about how to do this, and so you can find those directions in the back of your book. Okay, to start, what I want you to do is you're going to go to the back of your textbook, and it's going to be in the appendix. It's going to be on page 259. It says appendix 1 right here, but it's actually appendix 2 on page 259 in your book. And so if you want to go there, this is going to give you instructions for how to use Desmos, and then if you turn the page, on the other side, it will give you instructions for how to use the TI-83 or 84. I'm going to show you here, but that's where you can find instructions to do this. So if you forget, you can always go back there. So you're going to also need access to your world's tallest man information from the last lesson from your homework, and you're going to be using that. We're going to go ahead and try this out with a calculator. We're going to use the data in the temperatures and latitude table at the end of these notes. So if you look at the end of these notes, you'll find this temperature table. So that's the one we're going to use. If you are not using a TI-83 or 84 calculator, go to desmos.com, and you're going to click on where it says Graphing Calculator, and you'll see this screen. And then you'll need to go from the directions in the book. If you're going to be using the calculator, then I will show you and insert a video showing you how to use the calculator for this lesson. What we're going to do, we are going to find the equation of the line of best fit according to our calculator. So in the last lesson, we practiced finding the line of best fit using point slope formula and getting 2 points from our line. And we saw how it's a little unpredictable because everybody can get a different equation, and you know, they can be kind of similar, but they're kind of different, and so it's pretty hard to come up with a good equation of best fit. And we're going to talk about what all these things mean. We're also going to learn how to find a correlation coefficient. So we talked about what that is last time, but this time we're going to learn how to find that and also determine the strength of the relationship. Okay, to use your TI-83 or 84 calculator, we're going to start by clearing the memory. So to do that, remember you do second plus and then 7, 1, 2, and that clears out the memory so that you're not dealing with other trash that might be there. Now this next step is very important, and it's one that people tend to forget, but then you find out when you really need it that you forgot. And so you want to try to remember this at the beginning of the problem and not have to go back at the end because you forgot to do this at the beginning. So what you're going to do is you're going to do a couple of things in preparation for what we're doing. And if you look in your book, the next step, it says to turn on stat plots. Now this is something you want to turn on for what we're doing here, but in the future, if there's a problem with your graphing, see if your stat plots are on. They should not be on otherwise unless you're making a scatter plot. So we're going to go to second, and then up here where the y equals, we're going to click on stat plot. And you see that right now it says stat plots, and see where it says plot 1 is off. And so we want it actually to be on. So what we're going to do is we're going to hit enter, and we're going to, now it's blinking on, and so I'm going to say enter again. So now the stat plots are on. So now I can quit, so second and then quit. So now I'm back to my home screen. This next step, this is step number 3 in your steps back in your book. This one is the one that if you forget this, that you'll know it at the end of the problem. You're going to do what's called turn diagnostic on. So you're going to do second, and then you come down here to 0, and above 0 it says catalog, and that's what we're doing. We're going to a catalog of commands. And so in our calculator, it has a lot of commands that it recognizes, and it's in alphabetical order. And so we're going to scroll all the way down until we get to diagnostic on, and we're going to click on that. So probably it's just faster to just click down. So I see it now, so I went past it. So I'm going to go to my little arrow so that it's on diagnostic on, and I'm going to hit enter. So it says diagnostic on my screen. Now you have to hit enter again so it says done. If it doesn't say done, then it's not on. It doesn't appear to do anything right now, but that's something that we have to have done. The next thing we're going to do is we're going to enter our data. So if you look at your data that we're going to enter, it's the temperature table. And so I'm going to show you how to get started with that, and then you can pause the video and enter your data. So what we're going to do is we're going to go to Stat, and then we're going to hit Enter because we're going to edit, and so I want to edit something, so we hit Enter. And you should see List 1, List 2, List 3, and so on. If you do not see List 1 and List 2, then we need to do something else. So let me know if you don't see that, okay, because that will cause problems. Maybe at the end I'll put what you need to do for this, just in case. So what I'm going to do is in the List 1, I'm going to enter all the latitudes. So I'm going to type in 0.4, enter, and then 4.6, so you see where I'm going with this. And so I'm just going to enter all of those latitudes that I see in my table. And so you can pause while you do that. When I get all done with those, I'm going to use my right arrow and go over to List 2, and I'm going to enter the temperature. So 86 and then 70. It's very important that you don't skip any. It's very important that you don't mismatch. So 9 degrees north goes with 88 degrees, 14 degrees goes with 88 degrees. You need to make sure that you're getting this exactly like it says in your table. So go ahead and pause the video and then go through and enter all your data and then come back. Now that I have entered all of my data, so before we move on, you want to make sure that when you scroll down, make sure none of the numbers look out of place. Like when I first did that, instead of a 40 there, I had a 4. So I need to just make sure, because if you have any of these numbers wrong, it's going to affect what happens. You also have to make sure that it's even. You cannot have one more number in List 1 than you have in List 2. They have to be exactly even because they're ordered pairs. So once you've made sure that those numbers are right, then we're ready to move on. So the next thing we're going to do is we're going to learn how to make a scatter plot in the window, like see a scatter plot. Now this is not absolutely necessary in order to find the line of best fit, but it is interesting to note. So to make a scatter plot, we turn the stat plots on, and if you don't turn stat plots on, it's not going to show a scatter plot. The next thing we're going to do is we're going to adjust our window. So all of these numbers, like my x's, they're going from 86 down to 64. So if I go from 0 to 100 on my x-axis, that's going to be okay. So I'm going to click window because I have to tell the calculator where do I want to look. I don't want to go from -10 to +10 on the x-axis. I'm going to go from 0 to 100, and that's the latitude. And I don't want to go of a scale of 1. I think I'm going to go a scale of 5. So it's going to go 0, 5, 10, 15, 20. And then from my y's, so how high did the temperature go? My y's are going to, and if you aren't sure, you can look back at your table, but the y's, the temperature of it's going to goes from anywhere from 20 something degrees up to 86. So I think 0 to 100 would be good there too. You want to give yourself a little bit of space. Make sure you do the y min as the smaller number and y max as the larger number. If you mix them around and accidentally put 100 and then 0, it's going to give you an error. So you cannot mix those around. Okay, and then 5 is going to be my scale. So again, 0, 5, 10, 15. You can change that if you want to go 10, 20, 30 and just kind of see how it looks. But we're telling our calculator where to look, and then I'm ready to graph it. So when I hit graph, it's going to make a scatter plot for me, and that's all my data, that's all my temperature. And you'll notice that it might look a little bit skewed, but that's because the window is rectangular, so don't worry about that. Now, if you're not seeing this, then you need to go back and look at your window. Is your window set up just like mine? Also, you need to make sure that you did turn stat plots on. If you didn't turn stat plots on, you're not going to see anything. So if I went and turned stat plots off, so if I go to off and then I go to graph, I'm not going to see anything because it's not turning those plots on. So in order to be able to see what you want to see, you have to have your stat plots on, and then you'll be able to see your scatter plot. Okay, so once we've seen our scatter plot, that's interesting and everything, and that just can kind of give you an idea of what the data looks like. But what we're going to do now is we're actually going to use the calculator to find the line of best fit, and this way we're all going to get exactly the same line. This is going to be exactly the line of best fit. And so to do that, you're going to go to Stat. This time we're going to go to Calculate. So this Calc right here, so we're going to go over to the right to Calc, and you see it has all of these different opportunities. Now the one you choose is very important. For this one, we're going to go to number 4 where it says linear, and that means regression. And notice how it says AX plus B. That's like MX plus B. I don't know why they didn't do MX plus B. It would have been a lot less confusing. Notice how 8 is similar, but it's not the same. Okay, that's going to give you numbers in a different way, so don't do that one. Number 9 is absolutely not the same, so do not choose that one. Number 4 is what we're going to choose. So you can either use your down arrow, or you could just click number 4. Okay, now mine is a TI-84, and most of you guys might be working with a TI-83, and so yours won't look exactly the same. When you use a TI-83 and you go to Stat and Calc, it's just going to say the linear regression. So let me go back to that. It's just going to say what this lin reg, it's going to say that, and then the x plus b, and it's going to have a blinking cursor, and you're just going to hit enter. If you have a TI-84 like I have, it's a little bit of an extra step. It's just verifying we're using list 1 for my x's, list 2 for my y's, and then we're just going to go down to calculate, and we're going to say enter. Okay. Now, you should get this on your screen, and you should get exactly these numbers. If you only have y, a, and b, and you do not see the r squared and r, that means you did not turn diagnostic on. And so you have to go back to that step that I told you that you have to turn diagnostic on. If you don't turn diagnostic on, it's not going to show you those last 2 numbers. So look at what it tells us. It says y equals ax plus b. That's like y equals mx plus b. So a, that's my slope. A is negative 1.1486. So my slope is negative 1.14. And so and then my y-intercept is 94.13. And so what I'm going to do is I'm going to get my paper and I'm going to write that down, because that's one of the things that we have to do is write down what my equation is. Now we do have to figure out how to round this, and so depending on how I tell you to round, I might tell you to round to the nearest 10th or the nearest 100th. In this one it says round to the nearest 10th, so I'm going to go negative 1.1 for my A or my M, and then for my y-intercept, my B, I'm going to say 94.1. Okay, so then I'm going to go back to my paper and I'm going to write that down. Based on what my calculator tells me, I'm going to write my equation as y equals negative 1.1x plus 94.1. And we're all getting exactly the same because the calculator is calculating it based on the same data. So if you didn't get those numbers, it means that maybe you mistyped something in your calculator, in your data, and so you need to go back and check that. Now write a sentence explaining what the slope represents. So if we say negative 1.1, what are we talking about? So let's go back to the context of our graph, or our table. We're talking about the latitude. So if you think about the Earth, and 0 latitude is at the equator, and then we go up, so that's going to be like at the North Pole. And so if you're like at 86, you're really close to the equator, and if you're at 20 something, you're getting closer to the North Pole. And so what's happening in January? So up here it's getting colder, and then at the equator it pretty much stays the same all year long. So at the equator my latitude is 0, and so if I have a smaller latitude, so as my latitude is smaller, my temperature is higher. And so if you think about what that sounds like, if I was to graph this at 0 at my equator, it's going to be a high temperature, and as I get a higher latitude, meaning closer to the North Pole, it's going to be a smaller number. So this is going to show negative correlation. If you look at what your calculator says, it has a negative slope, and that's why it has a negative slope, because this is negative correlation. When we go to write this down, the negative slope tells us negative correlation, so we know that that's what it is. The next thing where it says to write a sentence explaining what the slope represents, here's a really easy way to do that. Remember that your x numbers, if you look at your table, the x was the latitude and the y was the temperature. So I'm going to just put latitude and y would be temperature. And since slope is y over x, I'm going to say temperature and over latitude. And that's in degrees north, so that's going to be important for me to say. And so since my slope is negative 1.1 over 1, so to speak, that means for 1 degree north, my temperature is going to go down 1.1 degrees. So if I start at the equator, okay, and if I go north 1 degree, my temperature is going to drop 1.1, and it's going to get colder and colder and colder for every degree that I go. And so that's what that says. So for each degree north that I move my latitude, my temperature decreases by 1.1 degrees. Fahrenheit. And so that's what the slope means. And so when you tell me what the slope represents, you have to be detailed and you have to tell me about both variables there. Write a sentence about what the y-intercept represents. What is the 94.1? So because it's a y-intercept, if you think about that, that means that when we're at 0 degrees latitude, the temperature is 94 degrees. So that means at the equator, the average temperature in January is 94.1 degrees. Now remember that when we're doing line of best fit, we are doing a trend. It is not a fact. It is not going to hold true 100% of the time. It's just showing the trend based on the data. So if we go anywhere in the world at the equator in January, that doesn't mean that every single place in the world is going to have 94.1 degrees. It's going to vary on mountains, valleys, ocean, whatever. And so it's just showing us a trend. And the trend is as you go further north in January, it's going to get colder. And so just understand that it's not a 100% fact. The next thing we're going to do is we're going to go back to the calculator now and talk about the correlation coefficient and how we find that. Using the calculator, please note that we're going to go to the thousandth. So I'm going to come in here and write my correlation coefficient, round it to the thousandth. Now make sure it's negative, because if it's negative correlation, your correlation coefficient will be negative also. So you need to make sure that you put that correctly. So negative 0.907. So a couple things to watch for. Make sure you round to the right decimal place. Make sure you've got your negative. All right, and then the strength of the relationship. So that goes back to last time where we said if it's between 0 and 0.5, then it's weak. If it's between 0.5 and 8.8, it's moderate. And if it's 0.8 to 1, then it's going to be strong. And that goes the same way whether it's positive or negative. This is going to be a strong negative correlation. And so you're going to use both of those words, strong because it's a 0.9 and negative because it's a negative. And so that's the information we're going to get from our calculator. Okay, for the next exercise, we're going to use the graphing utility. So again, if you're using Desmos, you have to go through the instructions in your book. But on the calculator, I'll show you again how to do this, but we're going to do some actual data. And so back in March, I started keeping track of how many cases of COVID-19 were in Utah. This might be a little soon, I don't know. But how many cases were in Utah? And so it's X is the month since March 3rd, 2020. So 0 would be March 3rd, 2020. There was 1 case in Utah. And then 1 would be April 3rd, 2020. There were 1,012 cases in Utah. Number 2, okay, there were how many cases in Utah? And so 7 months after, that's November, no, that's October, because 3 plus 7 is October. This was October 1st. Now, as you're watching this, numbers have changed quite drastically, and I'm recording this in December, and so we're 2 months down and we're closer to 170,000 at this point. So there's more data, but when I made this, I didn't have any more data than that. So we're going to enter this data into a scatter plot. It's obviously not going to have as many points, but we can still do it. So let's go to the calculator. Your calculator, what we need to do first is get rid of all of this. Okay, so let me show you how you can do that. Now, one way you could just clear the memory, and that's pretty fast, but you need to know how to do this too. So if you go to Stat, and then Edit, and then I'm going to go down to Clear List, and then I have to tell it I'm going to clear list 1 and list 2 because that's what I used. So I'm going to do second, and then see above number 1 it says L1. And then I'm going to do a comma because I'm going to do another list as well. And then I'm going to do second, and then above 2 is L2. And then I'm going to hit enter, and it says done. So now when I go into Stat and Edit, I see it cleared out list 1 and list 2. That's one way you can do it. Now let me just enter some stuff in here. I'm just going to put some numbers in so I can show you how to clear it. And so let me get some numbers. So let's say I have that and I want to clear it. So another way that you can do it is you can go in this list. So you go Stat and Edit and you have all this stuff. So if we had last times, you can actually go up here to list 2. This is very important that you do the right button now. You need to hit clear and enter. So down here it says list 2, and then you hit enter and it's going to clear it. And so then you can go over to list 1, you go up to where it's highlighting list 1, and again you clear it, enter. Now, the thing that people do that messes you up is if you go up here and if you hit delete, look at what happens. It's totally gone. List 1 is gone, and that's going to be a problem because then when you go to calculate your line of best fit, it no longer has a list 1, and it's not prepared to deal with list 2 and list 3. So we need to get list 1 back. So if you open your calculator and you do not have list 1 and list 2, the way you get it back is you go to Stat, and down here at number 5, Setup Editor, you're going to do that one, and then we're going to hit Enter. And now if you go back in, now you have all of your lists back. And so that's how you would do that. Okay, so I'm going to enter this COVID-19 data. So I'm going to start with 0 months, and then 1, 2, 3, 4, 5, and 6, and 7. Oh, whoops, and I messed up. So anyway, you can go ahead and pause and enter your data, and I'm going to enter mine. And it won't take very long, and then come back and we will see what happens with our data. You do need to be really careful as you're entering your data that you are not typing wrong numbers, because obviously that's going to give you a way different set of information. Okay, so we look at this, and this is what we have. Okay, so I'm just comparing my numbers and making sure I've got that. So you need to make sure, notice how my lists are even. I can't have uneven lists. Okay, so I'm going to make my scatter plot. Now my scatter plot, I don't need to go from 0 to 100 on my x's because I'm only going from 0 to 7. But on my y's, I need to go from like 1 to 120,000 or something like that. So I need to change my window so I can see my scatter plot. So I'm going to go to Window, and for my x's, I'm going to go from 0 to 10. Okay, so 10 months after March would be January. And I'll go by ones because 0 to 10 isn't very many. On the y's, that's where I have the number of COVID cases. I need to start at 0, but I need to go all the way up to 120,000, maybe even more. So I'm going to give me a little bit of space. You don't want to get it too tight on the graph. So I'm going to go to 130,000. I don't want to go a scale of 5. That's going to be like 5, 10, 15, 20, all the way to 130,000. I think I'm going to go more like 2,000. Whoops, not there. I think I'm going to go a scale of 2,000. So it's going to go 0, 2,000, 4,000, 6,000. And that way I'll get to 130,000 without too many little increments. And then I'm going to graph this, and here's my data. Okay. All right, so now when we look at this, if I was to draw a line of best fit, I could draw a line that maybe looks like that. But that doesn't really fit the data. Do you guys notice how it looks more exponential? That looks like an exponential curve. And so when COVID first started and they were saying flatten the curve, they were saying like, let's make this not exponential. And that's not what's happened. It's gotten exponential, and this is throughout the world. But so we started down here really small, but then it's just increased faster and faster and faster. And if you wanted, you could look up the data for, November and December and even January, depending on when you're doing this, and find out like what the cases are. And hopefully at some point it's going to go down, but right now it's still rising like that. So the problem is if I do a line of best fit, that may not fit very well. Let's just try it. So if we go to Stat, and then we go to Calc, and we do linear regression, that means we're going to find a line. So I'm going to go down to 4, and I'm going to do that. And then I have to do my calculate. So that's my information. So I've got my slope is 16,419, so 16,420. And so what does that mean? That means that every month we're getting 16,420 new cases per month. Okay, the y-intercept, if we go back to 0, like if it would have been linear, because this is linear regression, then the y-intercept should have been at negative 20,000 in March. So obviously that doesn't make any sense, okay, but I'm going to write it down anyway. So negative 19,389 cases, and I'm going to go and I'm going to graph this. So if you go to y equals, I'm going to type in that equation that my calculator just gave me. So I'm going to type in 16,420 times x, and then I'm going to say minus, because my y-intercept is negative, 19,389. Okay, now go graph that. Does that line fit the data? It does not fit the data very well. So because this is exponential, I actually don't want a line of best fit, I want a curve of best fit. So I'm going to go over here to calculate, And instead of going to linear regression, I'm going to scoot my way down the menu, and you see that after 9 it's got an arrow. That means it keeps going. Exponential regression. So right here, this is if you see that it's exponential, you can get an exponential curve for it. So I'm going to hit enter on that one. And then again, we're using list 1, list 2, calculate. This is going to give me different. So now notice it says a times b to the x power. That's exponential. A is 53. That's my initial value. Okay, so that's what we'd start with, 53.24. I'll just round to the nearest whole. So 53 times 3.79 to the x power. And so that means that in March we started with 53, which obviously we know we didn't, but remember this isn't perfect. It's following the trend. So if we had 53 in March, it more than triples. It almost quadruples every month. And so let's see how this fits the curve. So I'm going to go into my y equals menu. I'm going to keep that line right there. I'm going to go down to y2, and I'm going to do a second curve. And so I'm going to type this one in. It's going to be 53, and then I'm going to do parentheses to do my growth. So 3.79, close your parentheses, and then to the power of. Now in mine at TI-84, it actually shows the exponent. If you have a TI-83, it's going to show the little up arrow, the little caret, and then you'll type to the x power. And so this button right here, that does your variable. That's your input variable button. So whether it's x or t or theta or n, we use that for the input variable. Okay, now graph it. See what it looks like. Okay, that's not perfect either. So you kind of have to decide like which one is better. Okay, so I would say I can see that the shape is exponential. So if I go into y equal and I just take off this one, so if I clear that one and I just graph that one, it's better. This is such a different situation. If I had more data, I would be able to fit it better. So if I had November and December and January and February and March, if I had months and months of data, or if I had data from all across the country instead of just Utah, because in Utah it wasn't growing very fast at first, but now it's growing really fast. And so you have to recognize that this isn't going to be perfect. Okay, so my equation though, if I go back to second quit, and so I get my home screen, oh whoops, that didn't do it. So I'll just do stat and calc again. And then 0 was my exponential regression. Okay, so I'm going to write that down on my paper. Okay, so I'm going to classify this as exponential, so you should have circled that. The equation is going to be y equals 53 times 3.79. I'm not really telling you how to round it here because we can just use our best judgment there. Now, where it says R, look back at your calculator. Your calculator says 0.85. That's still in the strong category, but notice how it's closer to moderate. See how it was a lot less strong than it was on our previous problem? On our previous problem, we had a much stronger correlation than negative 0.9, so that was stronger. But since this is getting, 0.85, that's a little further away from 1, so that's going to be a little less strong. So it's still considered strong, but just not as strong. Okay, and that's why the curve in your calculator, that's why it doesn't fit the data as well. And so you can imagine if we had like a 0.5 correlation coefficient, it really wouldn't fit very well at all. And so really, unless it's strong, you're not really going to be able to tell if it's exponential or linear. Okay, so then the last thing we're going to do here is we're going to enter the data from the world's tallest man. So I put the chart on the notes again, but you're going to use it to compare what you had from last time. So you're going to go back to your calculator, and I'm not going to show you on my calculator this time. You're going to do this yourself. But you're going to go back into your calculator. Remember that you need to clear your list. Okay, so clear your list, and I showed you a couple ways to do that. And then you're going to, in L1, you're going to put the age, and in L2, you're going to put the height. Okay, and then double check and make sure you have all of it. And then you're going to go and you're going to calculate. And you saw when you did this in your homework last time that it was linear. So you're going to choose number 4, which is linear regression. And you're going to use that to write the equation, and you're going to use it to write the correlation coefficient. So come back here and start the video again when you get to that point. Okay, if you entered everything into your calculator correctly, for the equation you should have gotten y is equal to Your slope would be 2 point, and it says round to the nearest. It doesn't. So we're going to make a decision. I'm going to say 2.6. Now, if you did 2.57, that's perfectly fine. Don't want to round to 3. That's a little bit too drastic. And so we're just going to keep it at the tenths. And then plus, and then the y-intercept is 51.846. So I think I'm going to go 51.8. Don't worry, on your test and quiz, I'll be sure to tell you what to round to. The correlation coefficient, it is a positive slope, so it should be a positive correlation coefficient, and 0.9959. And so when you round this, you do not ever want to round this to 1, because that would mean that it's perfect. And so even if it's like 0.995, you cannot say 1. We're going to say 0.99. Now, if that 5 was a 9, I would have to go out another decimal place. So I can say 9959, or I can say 0.996, but we always have to show that it's not perfect. So you have to go out at least enough places to see that. It is very strong correlation. So if you look at the scatter plot, and I don't know if you put that in your calculator, how you can see the scatter plot, but you saw it on your paper last time, it's a very strong correlation. The points don't go far from the line of best fit. Okay, so you are going to now practice with your assignment with your calculator, and so you want to make sure that you're putting things in right. Go back and look at the steps if you need to in your book, but make sure that you're able to use your calculator to find the line of best fit and the correlation coefficient. It's not crucial that you can make a scatter plot, although that's interesting, and sometimes you really need to see if it's exponential or linear, and so that's something you should know. But as far as like being able to find the line of best fit, that's the most important thing. Don't forget to always turn diagnostic on. Every time you clear your calculator, if you do the second plus 712, you have to turn diagnostic on again. And so just remember that. So go ahead and do this assignment and then check your work and make sure you're doing it right.